Last week I made a valve for a Sentinel steam wagon. It was a drain valve for a steam brake cylinder, and I'm going to make an adapter for it because the hole in the cylinder is not deep enough for the valve we made. So I'm going to drone here. Everything's the same as a drone except that dimension there, that's going to be 1/2 inch BSP. The rest all the same. I'm going to use the bronze instead of stainless because stainless is a pain in the arse to work with on a job like this. I've got a bit of nice bronze bar here. I've got a few of these given. I'm not quite sure what for. It's got a hole all the way through, some threads in there. But I'm going to use a piece of that. It machines really well. The first thing I'm going to do is the external 1/2 inch BSP threads, and I'm going to use a die to do that, just to save changing all the chain gears over in the lathe, because I've got metric stuff to do. We'll machine the end square, and then we can turn it down to the right size, core size for 1/2 inch BSP. I think it's about 21mm. We'll have a look. The core size for the thread is 21mm. That's a 1/2 inch BSP parallel top. I've set the 0 on the vernier at 21mm, so that's a direct reading what needs to come off, 3.5mm. This should leave 0.6 to come off, 0.69. I'm going to use a split die to put the threads on with. Now, the last time I used it, it was set up to give a good tight thread. I may need to back it off slightly. I'm not sure. See if it will actually go on. Just going to do it by hand. It's a nice new well stock die, and it feels like it's cutting threads very nicely. Nice bright looking threads in there. exactly what we need. Happy with that, looks good. And that's the adapter we're going to use to machine the flats on there. He wants 10mm thread on there, so we can, that's on the last thread there, 10mm from there. Just take the end off and then put a nice lead on it. That's 10mm there. The wheel size he's given us is 15 and this is already at 14, so I'm just going to leave it there. It's not that critical. Just make sure you've got plenty clearance between your chuck and your tool when you've got things at funny angles like this. Lovely, settle for that. I'll part it off the length now and then do the internal thread, and then there's just the extra machine on there. Right, we want 25mm from there. So what they're doing just DROs, it just looks like more than 25mm, that's all. Right, we need that boring out to be the right size so we can tap it 1/2 inch BSP parallel, which is 18.75. 15mm thread and a 5mm undercut at the end. Start off with this boring bar and then progress into something different, I think. Zero, the DRO there. There's one for 20mm. And near 18.75. I'll put it back in just as a spring cut, see what it takes out. Funny his hair more and that'll be it. I need an undercut in the bottom of the hole, and I think what I'll do is use this screw cutting tool just to put the undercut in. I've got a BSP T-tap to start it. It's the same thread, just a taper. And I've got a parallel tap to finish it off. I'm just going to do it by hand once again. Not sure how good this tap is. Feels nice actually. The centre in there just to keep it in line. I'll get a shot so you can see the centre, so you can see how it works. And you just keep a little bit of weight on the tailstock hand wheel as it's going in. This probably would have power tap, but right, that's all the way home. It's amazing that this BSP thread, this fitting I'm making here is going into a steam engine that's nearly 100 years old. And even now, if you buy a new machine, a hydraulic machine, you'll probably find it's got BSP threads on it. Sort of a worldwide standard for pipe threads now. There is other threads, but BSP is really, really popular. This is a top or bottom, I'm not quite sure what it's like. It should be good. Yeah, it's cutting fine now. A little bit of advice, take that out of there. That wants to cut your hand open. I've done it, it's not nice. Don't leave centres and tailstocks, drills, anything like that, because it'll get you. This is the setup for machining the 6 flats collet block. I've screwed a tap back in to use that. Little jack on there to stop it flexing. I need 2 mil off each face. We'll start things up. Touch this off. And 0 the Z axis. And we'll go for, try a 1/2 mil cut first. Taking that easily. That's a 1 mil cut. It will probably take us all in one go actually. This brings it up to the 2 mil which we need. The bastard's going to hit that. It's hitting the back end of that pipe fitting. Not the end of the world, we'll put a flat on there as well. That's it there, 2 mil. Right, we'll carry on now I think. Right, that's the first flat done. Simple case now. turning this one flat. I keep saying this, but always stop the machine before you go anywhere near it. It'll have your hands off that. It doesn't really care what it's doing. I don't think this hexi block's the most accurate thing in the world. Yeah, that's taking the full 2mm, no problem. Same again, one flat. Yeah, you can see it's running out. That current block must be quite a way off being true actually. And I need to address. Well, the difference that makes it just look so much better, that makes it look finished off. I'll have a look at that current block this afternoon. I'm not happy with that. I'll make another one. It's fucking miles away that. Miles away. Not happy. Better. Not right, but better. Carefully. Once again, it's time to say thanks for watching, thanks for subscribing. If you haven't subscribed, please do. It is important. We've got well over 100,000 now. The figures are looking really good. Anyway, thanks for watching.